Okay, welcome to my workshop. What we're going to do now is we're going to, or I should say, you are at home are going to do the same series of labs that Galileo did when he first invented the controlled experiment. And remember, the idea is you isolate the variables. What I mean by that is you test it to where you're testing one variable at a time, and every other variable should be controlled, which means it stays the same. And so what we're going to do is the first experiment that Galileo did where he tested to see if the distance it swings, how big a swing it has, if that affects its rate of swinging. In other words, if that affects how many times it swings in a minute. Okay, so what you're going to have to do is make a pendulum, and you're going to hold it out three different distances and time it. So you're going to need to have a timer, like your phone, for example. Get it set up to be 30 seconds. I find 30-second timing is better, and then just double the number. 30 seconds is half of a minute. Okay, so get that ready. And so to get your pendulum, I asked you to gather some materials. Now, one thing I want to say right off the bat is make sure you have your parents' approval on what you use for the pendulum. I don't want it to be anything that's going to be fragile or broken or dangerous or hurt the floor if it slips and falls or something they're going to miss. Like, don't use your mom's car keys or something. She'll be, oh, my car keys. Don't do that. Look around and find something that'll work as a pendulum. The idea here is it should be able to swing freely, and you really want to minimize other variables like wind resistance. So for example, if you get a ping pong ball, wind resistance? No way, it doesn't have wind resistance. Or too much wind resistance, right? Or this kind of ping pong ball, something light like that just won't work. What's going to happen is the wind, just pushing through the air will be a major variable. If you get something with a little more mass, like a golf ball, this should work just fine. You know what works perfect? Fishing weights. If you get like a fishing weight, those are made of lead. When we do this in school in the classroom, that's what I use. Golf ball should be fine. Now this one here is like a tennis ball sort of thing. It's kind of borderline. You want something with a little bit of density, not something made of foam. Something else that might work, I don't know, this dog fetch ball has a hole in it already. I mentioned like a little teacup or something like that. This one here. You don't want it to be too big though. You're going to be hanging it, small. So keep it something fairly dense. This roll of electrical tape I use as an example. That would work. But something, one, it's not fragile where it's going to break. Two, where it's not going to break something else. Three, where it's not going to hurt you. Four, where nobody's going to miss it, right? Where it's like you aren't using the TV remote control and nobody can change the channel. All right. Item number one, get your materials. You're also going to need some string or thread of whatever kind you have. You're also going to need some tape or some method to tie it onto something. Find a location where it can swing freely. If you're gonna like the string, might have to use a door jamb. We'll see. But from under a desk, under a table, in a door jamb, I've got the ring stand here. That's what I'm going to use. You're going to also need some tape to be able to fasten it to that. And so, get your materials first. Do that. Now, after you've figured out what materials you're going to use for your pendulum, what kind of string you're going to use. Like, for example, here's one thing I was thinking. Like a little Yoda to swing back and forth. This one here, if you do use something like this, make sure it's kind of dense. This is a dense plastic. It's not like one of those little foam plastic. And it would work just fine. But what I'm going to use instead, I think I'm going to go for the golf ball. Okay? Get the golf ball and the string. Get your piece of string. Make sure you got a lot of extra string, right? It's only going to be 12 inches or 30 centimeters, but overhang is fine because you might as well plan for it to be fairly long. Because later on in another lab, it's going to have to be longer. Find a way to attach it to the item you're going to be using as the pendulum. In this case, I'm going to wrap it around and I'm going to tape it. Okay, I've got it taped to the string. Now I have to attach it to where I'm going to swing it from. Like I said, find a good place where it's not going to bump or rub. And now this is the part, this is really important. We want to make sure we're all using the same length of string. And when you measure the length, it isn't really just the string length that you're measuring. You also have to include half of the bob. Because technically, in a physical system, the center of gravity, the center of mass is in the center of the object. And that's what you have to measure to, is the center of mass of the object. So when you do that, when you measure it, okay, in this case, that's going to be 1 foot 12 inches. Oh, by the way, in school, we would be using metric. We go centimeters. That's 30.5 centimeters. But if all you have is an inches thing, I'm going to go by inches. Measure to there, not to there, not to there, but to there. Okay, and then you want to attach it, and you want to make sure when you put it on there, you tape it, double check that you got it right, and then finally you want to make sure you tape it securely enough that it's not going to slip as you're doing the lab, because that would be bad, and you'd have to just do it over. Okay, so down tape it securely to wherever you're hanging it from. Next up. Okay, once you have it attached and you have it measured out to where it's going to be, okay, that's 12 inches there, or 30.5 centimeters if you go in metric. Now what we're going to do, we're going to do a controlled experiment, so we're going to change only one variable. The mass has to be controlled. Duh! All you have to do is leave the same weight on there. That fixes itself. The length has to be controlled. Duh! Once you have it attached, just use the same one. The length is the same. But make sure while you're swinging it that it doesn't slip and get longer and longer. That can affect it. So don't let that happen. Now yours might be hung to like the bottom of a countertop where it can swing, or a table, or a door jamb, or something like that. But I'm using the ring stand, so just so you can see it more easily. And it's a pretty straightforward lab. The tricky part, if you're doing it by yourself, is to try to get the timing right and the count right. It's not that easy to look at a clock at the same time as look at the pendulum. So if you're going to be using like something with a second hand on it, maybe you could get a partner, a parent, a brother, sister, or something to help you out and do the timing. Or what's really nice, modern technology, if you have a phone that has a timer on it, set it to 30 seconds, start the timer at the exact same time, exact same instant that you release the pendulum, and then watch it and count it. And then when it beeps, stop your count. Okay, so that's a nice little tool that you might have at your disposal. So that's what I'm going to do. But no, we're going to be doing it at 3 different distances of swing, right? So one of them is 3 inches from the center. The other one is 6 inches from center, or use metric if you have it. Or the other is 12 inches from center. So we got 3 different distances it's going to swing back and forth, and count how many times it swings in a 30-second period. Double that to get swings per minute. So the technique here, of course, you can probably figure it out. Let me get this set up right. Okay. So I'm going to get it right here, where I put it exactly the right number, 1, 2, 3 inches, right there, and I hold it there. Get this out of the way. On your mark, get set, go. 1, 2, 3, 4, 5. The counter's counting for me, and I'm counting the pendulum while the timer's going. Notice that a full oscillation back and forth counts as one swing, okay? One full cycle. So count it every time it gets back to its starting point. Now, I could just do it for you and let you see that and tell you what the data is. What's the fun of that? Okay, you got to do it yourself, all right? But the second time, after you do that, repeat that 4 times, because that will account for... Oops, there's my 30-second timer. Okay, stop. So anyway, you want to repeat it 4 times, because sometimes you might accidentally go, ready, go, and let go of it just a little too late, or let it go of it a little too early, or whatever it is. And so the 4 times could adjust for that. You also want to remember, human error and stuff, you go within a margin of... Shut up! Within a margin of error, it should go, give or take 1 swing. Let's just say that that's going to be our margin of error, okay? All right. And then the second time you do it, it's the same setup, but you're going to hold it out 6 inches from center. Okay, that's 6 inches. And then ready, go. And repeat that 4 times. And then once you have the 30-second data, make sure you double it, put it in there, and get the average. That's what you're going to do. And after you get done with that, you're going to analyze your data, claim, evidence, and reasoning. Fill it out. State your claim about what you think the answer to the question is. Did it affect it? 2, give reason why you think that. Cite specific data within there. Oh, it's within the margin of error of 1 swing. Or no, it's like many more times swing. And use the numbers. Tell the numbers. 3, state the obvious. Explain how that data, how that evidence leads to that conclusion. All right? that's what you got to do. Go ahead and do it and have fun with it. Sure.